So let's do this with a couple of chemical reactions. So first, real one. Recycling two of the ones that I used in my first examples. That way they wouldn't seem unfamiliar to you. So did hydrochloric acid with sodium hydroxide, giving you water and sodium chloride, water and salt. And the masses are up here, so they should look really familiar. So you start off with 8 grams of sodium hydroxide and 6 grams of hydrochloric acid. And if you remember when we did these last time, when I showed them to you, I just gave you one ingredient and said, assume you can make as much of the products as you want, and how much of the other reactant would you need to go with it. Now the difference is, when you're given this, I'm saying, okay, you're given 2 starting materials, you've got to see if they're in the right ratio to begin with. So you can't assume, and you can even use that to tell you which question you're getting. If you're just given one reactant and it says make as much as you want and how much of the other reactant you need to go with it, you know you're just saying, okay, let's see what we theoretically we can do. That's going to come in key later. Here, you're saying, okay, do I match up? So I take my sodium hydroxide, I've got 8 grams. Oh, my molecular mass is 40 grams. So 8 divided by 40 is 0.2 moles. Let me make that decimal just a little bit bigger so it shows up a little better. 0.2. Okay. I've got 6 grams of hydrochloric acid. So 6 divided by 36.5 is 0.16. Okay, it's a 1-to-1 reaction. One piece with one piece. So in this case, 0.16 is less than 0.2. I'm going to run out of my hydrochloric acid just a little bit quicker than I will run out of my sodium hydroxide. Well, let's see how that affects my math. So I'll show you the rice table first and the math second. The nice part here is you no longer have to, when you're figuring out how much water you're going to make and how much sodium chloride you're going to make, you don't have to do your math based on the sodium hydroxide and the hydrochloric acid. You can ignore this when you do the math method. You can focus on this because you know it's your limiting reagent. If you do your rice table, it's still not going to be that much extra work. You're just going to know that with your water and your sodium chloride, how many in moles you're going to make because it's 1-to-1. It still keeps it easy for you. So let me switch things around here really quick. Get this out of the way. And let's see what happens. Okay. This is how your rice table looks. And again, remember, with your rice table, you're in moles. And I didn't put my weights up here. Hopefully you can remember. All right. So with the hydrochloric acid, I've got 0.16 moles. The sodium hydroxide is 0.2. I don't have any extra water or salt to start with. So when the reaction runs, I'm going to lose all of my hydrochloric acid. I'm going to lose 0.16 moles of my sodium hydroxide, but you can see already I'm going to have a little bit left over. This is going to be a plus 0.16. This is going to be a plus 0.16. So when everything is over, my hydrochloric acid is gone. I've got 0.04 moles of my sodium hydroxide left. I've got 0.16 and 0.16 left. Okay, well, how much water did I make in grams? Well, I've got 0.16 moles, but it weighs 18.0 grams per mole. Oh, well, that's going to give me grams. Put that number up for you in a second. What about sodium chloride? Same concept. Sorry about that, guys. I've got 0.16 moles. My mass is 58.5 grams per mole. So when those come in for my numbers, 2.88 grams of water and 9.36 grams of sodium chloride. Now, one thing that I hope you guys saw that when you were doing these problems before is that when you do the math method and you don't do any rounding to fill in the table, is that sometimes your answers are a little bit different, and it's fine, okay? You have to round here because otherwise you would have like 5 or 6 digits in your table and you'd never get done. Don't worry about it. It's fine. So let's do the math method and let's see what happens. So 2.88 and 9.36. Whoop. And let's talk about what we're doing for our steps again here. Okay. So when you're doing, you're going on this first one, you're making water. So you're taking your 6 grams of hydrochloric acid. What's your first step? You're getting out of grams of hydrochloric acid and into moles. Okay, 6 divided by 36.5. Your next step is that you're doing your conversion inside your own reaction. So, I'm getting out of moles of hydrochloric acid and into moles of water. Last step, I'm getting out of moles of water and saying, okay, now I want to be in grams so I can have something that I can actually weigh. And when you do that, there are people that just hate it when I erase with my finger, and I'm beginning to understand why. It's 2.96 grams of water. And again, your answer is a little bit higher here because you didn't round off, and it's okay. You don't have to be keyed up over that. Second step, taking your same starting material, and this first step is exactly the same because you're trying to get into moles of hydrochloric acid. Your second step is your comparison. 1 mole of hydrochloric acid is going to turn into 1 mole of sodium chloride. The last step is just your conversion. Sodium chloride is a lot heavier of a molecule, so that same mole is going to weigh more. No big deal. And when you do that, it's 9.62 grams of nectar. Okay. Yeah, it's a little bit different than the answer you had from your rice table. You're close enough. You're in the ballpark. Okay, guys? So this is the first time of doing a limiting reagent problem. Next problem I show you is going to be a 1 to 2 reaction where you need to be able to identify which one's the limiting reagent. And all you need to do is compare on a 1 to 2 basis, or in the future, maybe a 1 to 3 basis. And it's really easy. Just take in your chemical equation the molecule that's got the 1 in the equation and multiply it. Make a comparison. You'll see which one you run out of first real quick. Okay? Be back in a jiffy.